Hello, Legacy Sabers. Marsh here. So today we're going to talk about exponent rules. This is a review from Algebra 1, so this is all stuff that you have seen before. I know it's probably going to act like you probably haven't seen it, but I know you have. So you're going to want your foldable and then a pencil today for this information. So first, the basics. X to the fourth means you're multiplying x by itself 4 times. So if I have negative 2x, or negative 2 to the fifth, x to the fourth, that means that I have 5 2's. Notice that negative 1 is not in the exponents. So technically I have negative and then 5 2's multiplied by one another. And then I have 4 x's multiplied by one another. Ultimately, then, we would figure out what is 2 times 2 times 2 times 2 times 2, which is 32. So this would be negative 32 x to the fourth. This idea of what an x to the fourth means, this can assist us when we're actually doing problems because it actually makes the rules make sense of exponents. But try to keep in mind that an x to the fourth just means you're multiplying x by itself 4 times. The first rule that we're very commonly using is the product rule. When you're multiplying things with the same base, that means the same big guy, you're adding your exponents. So for example, I have x squared, y squared times x to the fourth, y to the seventh. So ultimately, what I'm going to do is I'm going to add exponents of things with the same base. So I'm going to add the 2 and the 4 together because they both have an x. So it'd be x to the 2 plus 4. And then I need to multiply it because they're still multiplying, right? Y squared times y to the seventh. Well, that would just be y2 plus 7. So I would actually have x to the sixth, y to the ninth for my final answer. Now, think about how does that work? Well, x squared is an x times an x, right? And x to the fourth is x times x times x times x. Notice how many x's I have. I have 6 x's. Same thing with y's. I would have 9 y's if I wrote it all out. So by doing all that writing out, sometimes you can see why the product rule actually makes sense. The next one we want to talk about is power to a power. So when you're raising a power to a power, you're going to distribute the exponent to everything and then multiply exponents together if required. Because remember, squared means I got to write this thing twice. So technically I have 2 b's, right? B squared. So what I'm going to do is I'm going to basically distribute. Now I'm going to put distribute in quotation marks because you're not really distributing it, but it kind of looks like it. So I'm going to put the squared to everybody inside the parentheses. So that means I'm going to have 3 squared, a, and since I already had a squared, it's going to be 2 times 2 in those exponents. And I'm going to get b squared. Then let's distribute the 2 into these pieces here. So that would be 2 squared, a to the 4 times 2. Now, let's simplify. I have, and technically there's a big giant multiplication in the middle here, 3 squared is 9, a to the 4th, b squared, times 4a to the 8th. Since this is not all the way done though, right? Because we still have 2 bases of a. So I need to add those exponents together and I'm going to multiply the numbers because they're technically multiplying. So 9 times 4 is 36. And then I'm going to get a to the 4 plus 8, which is 12. So I'm going to get 36a to the 12th b squared for my final answer to that problem. The next one I want to talk about is the zero property. Any base raised to the 0 power equals 1. So notice I have all of this, right? Well, technically it's a power to a power, right? So I'm going to distribute the 0 to everybody. So I'll get 175 to the 0 power. X to the 29 times 0, since you're distributing, right? Which would be 0. And then y to the 0 power. Now, here's the cool thing. Anything to the 0 power, anything, is 1. The number 1. So 175 to the 0 power, a 1. X to the 0, another 1. Y to the 0, another 1. Oops, got so excited there. 1 times 1 times 1, that's just 1. okay? So anything, march to the 0 power, 1. Anything to the 0 power is equal to the value of 1. The next one we want to talk about is the negative exponent. So to make a negative exponent positive, because we don't want them to stay negative, it's not clean. We want positive exponents. We are going to move to the other side of the fraction bar. So if it's on top of the fraction, it's going to move to the denominator. If it's in the denominator, we're going to move it to the numerator. So for example, on this one, notice this x has a negative exponent. So this guy is negative. He has a negative exponent, and so is the z. So since I'm on the top of a fraction, this guy needs to move down to the bottom, and so does z. The negative is a saying I'm on the wrong side of my fraction. So I'm going to move the x to the negative 2 down to the bottom. By doing that, I'm going to get an x squared down there. So it's just going to make it positive for an exponent. But on the top, I do have 3y squared. They didn't move. They didn't have negative exponents. They had to stay up there. But the x gets to go down to the bottom and become a positive exponent. And then the z also needs to move down to the bottom. He's going to get a positive exponent as well, and that's going to be a 1. So z to the first. I then take a look. Do I have only one base of x? Yes. Do I only have one base of y's? Yes. Only one base of z? Yes. I cannot simplify that problem any further. I always check. Do I have one base of each of the letters? Because if I have multiple of that base, that's not done. I got to keep going. Now, when I have the quotient rule, so maybe I have the same base on top of one another, kind of like I have a p over a p, right? When that's the case, I subtract my exponents. So I'm going to first wait with the 2 over the 6. We can simplify that. That is a fraction, 2 over 6. That is 1 over 3. Notice I'm not subtracting that, though, because it's actually division. Now, I'm going to subtract. I'm going to go p to the 2 minus 3. 2 minus 3. Now I got to do the q. So that will be q to the 2 minus 1. Notice what I'm doing. I'm literally subtracting the numerator from the denominator. So I'm going to simplify. So that'll be 1 over p to the negative first and q to the first. We're still over 3. I can't leave this p to the negative 1 alone, though. It's a negative. So he needs to move down to the bottom. So I'll have an answer. I got to move over here. I'm running out of room. Q got to stay upstairs, but the p to the first had to move down to the bottom. Now, those ones, those exponents do not need to be there. I just wrote them there so we can see that it's to the first power each time. When I do my subtraction, actually what I consistently do is I find the bigger number. So I would go 3 minus 2, and then I see which one has more in it. So the denominator, that's why it would be p to the first. So if this was, maybe this was like a q to the 6th right here, I would go 6 minus 2, and then I would put q to the 4th down at the bottom because there was more q's down there. Reason why that's the case, think about it. This is p times p, right? P squared. This is p times p times p. Well, what I can do is I can cross off 2 p's with 2 p's, and I got a single p down at the bottom. That's why it's working like that. Power quotient. When you're raising a fraction to a power, you need to distribute the exponents and multiply the exponents together if there are any. So we're going to distribute this 3 to everybody. Now notice, I had to drive this 3 to the big 3 as well. Don't forget, the numbers on the inside, they also get that exponent on the outside. So it's going to be x to the 7 times 3, so we're going to multiply, over 3 to the 3rd, y to the 2 times 3. 7 times 3 is 21. 3 to the 3rd is 27. And y to the 2 times 3 is 6. No double x bases, no double y bases, and I can't simplify 1 over 27. So that is as far as that problem can go. And the final kind of rule is when I'm adding and subtracting expressions, you must have like terms. Kind of like when I had 3x squared minus 2x squared, that's just 1x squared, right? So I need to have like terms. Right now, I can't subtract these because I am not able to subtract. They're not like terms. So what I'm going to do is I'm going to do some simplification. I'm going to distribute this 4 in because it's a power to a power. So I'm going to have front part, not going to change. 2 to the 4th, that is 16. X to the 4th, y to the 12th. Because remember, we multiply 3 times 4. Now notice, I have the same exponent piece, right? Y x to the 4th, y to the 12th. I don't care about that anymore. I just need to subtract the numbers in the front. So I have 3 blah, 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 minus 16 blah, blah, blah. So I'm going to subtract the blah, blah, blahs, and I'm going to get negative 13 x to the 4th, y to the 12th. Notice, I'm not changing the terms. I'm just changing the coefficients. Because this is saying you have 3 of this value and you have 16 of this value. Subtract them is what you are doing there. Now, let's do a couple of examples of a bunch of information. So, first thing, I see power to a power is what I see first. So let's distribute this negative 2 in first. And let's distribute this 2 in the base. So I'm going to get 3 to the negative 2, w to the negative 4th, x to the negative 4th, over 2 squared x to the 5 times 2, which would be 10. I got a bunch of negative exponents, so let's move them all to the bottom. So, hold up. What's going to be on top? Oh, just a 1, right? If we yank everything from the top, there still needs to be a 1 down there. Well, 2 squared still down there. X to the 10th is still down there. I now have a 3 squared because that negative 2 moved down to the bottom. I now have a w to the 4th down there and also an x to the 4th down there. Okay? Now let's do some simplification. Let's combine some terms and also just do some simplification. I'm going to get 1 over 2 squared is 4. X to the 10th, notice I can group him with his friend. They are multiplied, so the product rule is coming into play. That would be x to the 14th. 3 squared is 9, and then I have a w to the 4th. Now be very careful, you're not done, because we do need to multiply that 4 and that 9. So I'm going to get 36 x to the 14th, w to the 4th. Lots and lots of steps. And the problem is you can take many steps with this program, or with this problem, and you'll probably come out with the same answer as me. Example 2. First thing I always take a look at is, can I move things? Can I do this y to the 0? The main thing is I try to move people. Notice, negative 6 can't move. It's not a negative exponent, it's a negative coefficient. So don't move the 6. 6 can't move. He's not a negative exponent. But this x to the negative 1st, he needs to move down to the bottom. Y to the 0, that's just a 1. So theoretically, he doesn't even need to be there. So I'm going to go shh and cross it out so I don't see him anymore. X to the negative 2, going to move him up to the top. Y to the 5th, got to go up there. And z to the negative 2's got to go up there. Now, let's clean what moved and what didn't. So it looks like negative 6 didn't move, and neither did z squared. But I did move an x squared up there. I did move a y to the 5th up to the numerator. And I did move a z squared up to the numerator. Downstairs still is a negative 42. He didn't get to move. But I did move an x to the 1st down there. And I think that's all that's in the denominator now. But now I need to combine some like terms, right? I do have a z squared and a z squared up to the numerator. So that would be a z to the 4th. I am going to write them in alphabetical order too. And then I do notice I have an x squared over an x, so I'm going to do my quotient rule. So that means I'm going to subtract my numbers. So I'm going to get x, because 2 minus 1, right? Y to the 5th, z to the 4th, over negative 42. No x's in the denominator any longer. But I do have negative 6 over negative 42. We do need to simplify that fraction. And we can simplify that into 1/7. So technically, I have the answer of 1x y to the 5th z to the 4th over 7 for our answer. Let's try the third example. Notice we do have a power to a power, so let's make sure we take care of that. So I'm going to distribute the 3 in. So we're going to get 5 cubed x to the 3 times 3, which would give us a 9, and a 2 times 3, which is a 6. Now, let's combine over here. We do have multiplication, so that means I need to multiply. So we're going to multiply the 2 and the 3. That's going to give us a 6. And then an x to the 4th times an x. We're going to add those exponents. That's going to be x to the 5th. And then a y to the 5th times a y cubed. That's going to be a y to the 8th. 5 cubed is 125. Write it all out again. You know what? I can't combine these. They're not like terms. I can't combine. This is as far as this problem can go. Kind of strange, right? Kind of looks strange. You're like, but Marge, there's 2 x's. Can't I just combine them? No, they're not the same things. So we can't combine. I'll be trying to like add apples and oranges. And that's just not going to taste very good. So we can't combine this. This is as far as this problem can go. Example 4. I got a lot of stuff to deal with in that denominator. So let's distribute the 4 in. And I also need to distribute this 2, it looks like. So that numerator, we're just going to let that numerator kind of hang out there. 3 to the 4th, x to the 16th, y to the negative 8, minus 37, x to the 16th, y to the negative 8th. Now, I can't move this y to the negative 8th. I can't move them because they're subtracted with one another. So I can't theoretically move these guys. But notice, I have like terms. They are the same thing. So I'm going to rewrite this 3 to the 4th as 81. And then I'm going to do some subtraction. I need to subtract those values. So I'm going to subtract 81 minus 37 is 44. So I'm actually going to have negative 4 x to the 14th, y to the 11th over 44 x to the 16th, y to the negative 8th. I now can simplify. I can move this guy up to the top because it's not subtraction down there no longer. So now I'm at negative 4 x to the 14th, y to the 11th, y to the 8th because it moved up to the top, over 44 x to the 16th. Let's do some more simplification. Well, negative 4 divided by 44, that fraction can simplify. That can simplify into 1 over 11. I'll get x squared down at the bottom because x to the 14th minus x to the 16th, because you're subtracting. 14 minus 16 is a negative 2, and then that would have to move down to the bottom. Also, 16 minus 14 is 2. There was more in the denominator, so it's down there. And then I got to combine my y's, so that would be y to the 19th for an answer. Let's try the next one. Go ahead. We're going to distribute the squared in. Now, make sure it goes to everybody. There is a lot of people that get that squared there. So we get x to the negative 4, y to the 0. Remember, you're multiplying. Z to the negative 16th over 3 to the negative 4, x to the 14th, y to the 6th, z to the 2nd. So I distributed everybody. Now I'm going to cancel out people and move people. Well, y to the 0, he doesn't matter no more, right? Let's move x to the negative 14th down, or x to the negative 4, excuse me, down to the bottom. Move z to the negative 16th, and let's move 3 to the negative 4th upstairs. So 3 to the 4th is still upstairs now. But downstairs is all the people that were down there, and an x to the 4th, and a z to the 16th. Those guys are all down there now. So now, let's combine our like terms and simplify. 3 to the 4th is 81. I got to combine an x to the 14th and an x to the 4th. Since they're multiplied by one another, I'm going to add. So we're going to get x to the 18th. I don't have any doubles of the y base, so it's just going to be y to the 6th. But I do have 18 z's hanging out. And the last problem, I want you to try on your own. Okay? Oh, can't spell today. Own. Okay? Try that on your own and then see if you get the answer. Check it with me when you see me next and see if you got the right answer so that you can make sure you got this exponent rules down. And that is the end of this video. I will work a lot. We're going to be working a lot with these exponent rules, and I will see you later, Sabers.